Hello, welcome back to my channel. This is Java with Ali and I am Ali. So today we are going to look at more concurrency. If you're unsure about any of these, this is in a series of videos. I'm trying to keep the videos short based on your feedback. So we're continuing on from the previous videos. So we're going to use 4 different classes today, and I have some of them already up on GitHub and I'll post them up again this evening. So we have producer and consumer classes, which we're going to use in this example as well. So this example is using array blocking queue. Now, array blocking queue, which is a great class because it's already inbuilt in Java in one of its packages. So we use the import java.util.concurrency, and it's array blocking queue, which is a fully implemented thread safe class where thread safe buffer class, I should say, that implements the blocking queue. It has 2 already classes that are part of blocking queue, the interface blocking queue. So one is put and one is take, and we mentioned those terms before a little bit, so let's put it on and take it off. So method put places an element at the end of the blocking queue, so we're putting it on the queue, and waiting if the queue is empty. And then we have take, which is removing an element, so taking it off from the top or the head of the queue, waiting if the queue is empty. So with array blocking queue, then it's a good choice to implement a shared buffer. So we have, because method put blocks until there's room for the buffer to write data, and method take blocks until the data reads data until there's new data to read even. The producer must produce a value first, and the consumer then correctly consumes only after the producer writes a value to the producer, correctly produces the next value until the produce. So basically it's in order, which is really nice. So producer has to produce something before it can consume something, before consumer can consume something. And with array blocking queue, we have put and take, and both of those methods only work. They waiting if the queue is empty for take, and waiting if the queue is full for put. So we have put it on, take it off, put and take. So we have here just a class called buffer, blocking buffer, which we'll go through first. Here we have private final, again implements buffer first. That's important. So this is our interface here. You can see here it says I for buffer, and you should be able to read a bit. Maybe not. Or you can open the declaration. Let's open the declaration and see. Come on, Eclipse, work for me. Let's come back to it. So we have private final array blocking queue. As an integer, we're going to pass in, and it's going to be called buffer. This is our constructor. If you're unsure of constructors, please check out that video. Constructor is the name of the class itself, and every time the class is called, we're going to call the constructor. This is an empty constructor, so it's overwriting the previous default constructor that's already there. So normally you don't, anyway, you can check out the constructor video for it. So we have here a new array blocking queue is going to be assigned to buffer. And here we have, again, I showed you this in the previous video. I think you can go to sort in Eclipse, you can go to source and generate getters and setters, and once you click on that, it should not generate getters and setters, sorry, override implement methods, and you will show you the override methods that are already built in when you implement buffer. So in this case, it's blocking put and blocking get. So we're going to put something in the queue. When it's called, we're going to put in a value here. It's throwing an interrupted exception, and then we're going to print it out on the screen. So producer writes value buffer cells occupied buffer size. Then we have our blocking get, which throws an interrupted exception as well. And we use the take buffer.take, which retrieves and removes the head of this queue, waiting if necessary until an element becomes available. And we're assigning it to read value, and then we're printing this out on screen and returning the read value as well. So you can see here the output, but first we're going to go to our blocking buffer test. And again, we're going to use our executor and our executor service. So exec service here to create our new thread pool. Note, you do not use the new keyword. This is executors and then the new cached thread pool, which is used. So we have executors here as part of this executors package. Executor service is part of this imported package as well. And then we have create blocking buffer to store our ints. So blocking buffer being our class over here. And it's going to be assigned to shared location. Then we're going to pass the shared location to producer, which is here, and consumer. And if you're unsure about these, please check out the previous videos. The GitHub code is up on GitHub already. So then we also, of course, we have to shut it down and await termination. That is, as usual, we have to do this. That is standard and normal throughout all of the previous exercises that we've done so far. So we have thread safe. It's a thread safe buffer. Blocking buffer implements buffer, which we know already. And then we use the classes producer and consumer, just to reiterate. So this approach then demonstrates encapsulated synchronization. So it's already there. The threads accessing the shared object are unaware that their buffer accesses are now synchronized. And the synchronization is handled entirely by blocking put and blocking get methods in the blocking buffer by calling synchronized array blocking queue methods put and take. So if we go back here again, you can see here our put and take are called here, put and take. And because they're called, they're already synchronized, they're already encapsulated synchronization. So thus the producer and consumer runnables are properly synchronized simply by calling the shared objects blocking put and blocking get methods. And today that is going to be the shortest video so far, I think. And we're going to move on to what I have on the list here: sort, parallels, timings, and then we move on to sequential versus parallel streams, and then accessing databases. So stick with it. The concurrency videos, there should be 2 more as part of this concurrency chapter before we move on to it. And just to reiterate, you cannot trust your program's behavior. That's why we use concurrency. Exclusive access, waiting threads proceed. Synchronizing shared access is mutual. There's mutual exclusion, and we should wrap up and do a little bit of a summary in the second last video. So the next video will be sort and parallel timings. The following one should be sequential versus parallel streams, with a little summary to wrap everything up. Okay, happy Sunday. Thank you so much for watching. Please like, share, and subscribe if you like it. Okay, bye.